Hi folks, we're going to take a look at question 4 from the motion in a straight line homework. Okay, this question is given a little differently because they just give us one graph and they're asking us to make a bunch of determinations based on this graph. Okay, so what's important to first realize is that this function represents the velocity. Okay, so this does not represent the position of the object with respect to time, it represents the velocity of the object with respect to time. Okay, so let's look at the first question. It says, when is the object stopped? Okay, so the object is going to be stopped when the velocity is equal to 0. Okay, so again, this is not the position function, so you're not looking for where you have a horizontal tangent, you're looking for where the velocity is equal to 0. Okay, now look at my function. I see the first time the velocity is equal to 0 is at this point here, which looks to be, so these are split up into 4, so this looks to be about 2.2. Okay, so it's stopped at 2.2 seconds. Okay, and we see that it's also equal to 0 here. So that looks to be about 4.9. Okay, so these are the 2 points at which are the 2 times where the object is momentarily stopped. Okay, so now the next thing we have to look at is when the acceleration is positive. Okay, so now since this is the velocity function, the acceleration represents the derivative of this function. Okay, so we need to see when are the slopes of the tangents positive. Okay, so here, let's start with this section here, and I see, yeah, the slopes of the tangents are always positive till I get to this point here, and then they start going into the negative. Now, we've already mentioned this idea that a positive slope, okay, a positive tangent, seems to imply that the function is increasing. Okay, so we notice in this interval that the function is increasing. Okay, so here we've got acceleration positive, so we'll start 0 less than or equal to t less than, and this looks to be about between 0.75 and 1, let's say 0.87. Okay, but this might not be the only area where the acceleration is positive. So here I see the slopes of the tangents are all negative, 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 and here, at this point here, okay, suddenly they start becoming positive again. Okay, right till the end. Okay, and we see again what is the behavior of this function here. When the slopes of the tangents are always positive, we see that it's increasing. Okay, so the other area where we have a positive acceleration is from, and we'll say we'll call that about 3.75, so t greater than 3.75. Okay, so let's look at the next question. When is I'm assuming this is supposed to be when is the object moving away from the point of reference? Okay, that seems to be the only possibility here. So when is the object moving away from the point of reference? So remember, when we talk about moving away and moving toward the point of reference, we have to look at both the velocity function and the position function. Okay, and depending on whether the signs are the same or different, that'll tell us whether it's moving away or moving toward the origin. Problem here is we're not given the position function, and we can't tell the position based on the velocity. So all the velocity tells me is about the motion of the object, the rate of change of the position. It gives me no indication whatsoever as to where the object is. So we can't actually answer this question. Okay, so here, not enough information. Okay, so again, knowing what the velocity is at any point gives me absolutely no indication as to where the position is located. So, question can't be answered. Okay, let's move on to this one here. When is the object speeding up and slowing down? Well, this one we can answer, okay, even without the acceleration function. So, if we had the equations, we would find the velocity and the acceleration functions and determine when they were both positive or both negative for speeding up, or opposite sign for slowing down. Okay, but here we're going to use the fact that the speed is just the absolute value of the velocity. Okay, so we need to find where the absolute value of the velocity is increasing, that means we're speeding up, or decreasing, that means we're slowing down. So what I'll do is I'm going to create two columns here. So we'll figure out where it's speeding up and where it's slowing down. So let's start with this first interval here. As the velocity is increasing, so since I'm looking for the speed, which is the absolute value of the velocity, I want to see its distance from zero. So I see here that the distance from zero of the velocity is getting bigger and bigger and bigger, okay, up until I reach this point. Then the speed, the absolute value of the velocity, starts getting smaller. So in this interval, we've got that it's speeding up. So from 0 to this point here looks to be about, I think we said it was 0.87, okay, less than 0.87. In that interval there, the object is speeding up. Okay, but now at this point, we see that the speed is decreasing, okay, until it reaches 0. So in this interval here, it's slowing down. So from 0.87, okay, to, and here this we said was about 2.2, the object is slowing down. Now this is where you have to be careful, because at this point here, while the velocity keeps decreasing, the absolute value of the velocity is increasing, meaning the speed is getting larger and larger and larger. So in this interval here, the object is speeding up, despite the fact that the velocity is decreasing. Okay, so between 2.2 and this here we said was about 3.75, we see that the speed is getting larger. Okay, but once we get to this point here, and we keep going, we see that the speed, the absolute value of the velocity, is getting smaller. Okay, so between 3.75 and 4.9, the object is slowing down. And then once I get to 4.9 and beyond, I see that again, the speed, the absolute value of the velocity, is getting larger and larger and larger. So in this interval here, t greater than 4.9, it's speeding up. Okay, so we see that we can get a lot of information just with the velocity function. Okay, so we can get information about the velocity, about the speed, about the acceleration. However, what we can't get is information about the position. Okay, so this is a limited scenario that we have. Okay, that's it for this one.